All right, so welcome everyone. I'm Marco, and today I'm gonna share my experience about introducing Kotlin Multiplatform in an existing project. I will share all the struggles that I went to it, all the good things and the bad things, so everything basically. So just a few words about what Kotlin Multiplatform is for who doesn't know. So basically, Kotlin Multiplatform it's a tool basically to share as much UI, as much code as possible into different platforms. There are a lot of platforms that are supported, but for this talk, we're going to focus more on the mobile part of the platform. So basically, for an Android and an iOS application. But there are more, of course. Okay. It's about an existing project, but before diving into an existing project, we need to understand how things work for a new project. So for a new project, basically, it's very simple to create one because there is a fantastic Android Studio plugin that you can use to spin up a new project. And by just a bunch of clicks, you can end up with a new project. And this project have everything inside the same folder. So basically, you're going to end up having a monorepo. And inside this thing, there are all the code that you need. So there is the folder for the shared code. There is an Android project, and there is an iOS project. So how things works? Well, for Android, it's pretty straightforward because the shared code is just a Gradle module. So it's from the Android perspective, it's just yet another Gradle module that you're going to use in your project. So basically, you don't need to do anything special to use it because, yeah, it's Gradle in both sides, and Gradle with Gradle, fortunately, can talk without any problem. The hard part comes on iOS, of course, because it's a completely different platform. Gradle doesn't talk with Xcode and the iOS toolchain. So the only way of doing it is to shipping a binary, because we can't ship a Gradle project, and of course, we cannot ship it in a different environment. So for this, for iOS, we need a binary, and there are two ways of building a binary. And the Android Studio plugin suggests those two options. The first one is the regular framework way, and the second one is with the Cocoapod's Dependency Manager. The first one basically exposes a Gradle task that you can call it to build the framework. Most of the time, you're not going to call it because it will be Xcode that is going to be calling it. So basically, this task, it's hooked inside the build phase of Xcode. So whenever you hit the play button on Xcode, this task is getting called, and the binary is going to be built. And this task is going to decide which architecture you have to use. So if you have to use an ARM64 architecture because you are using a simulator in a M1 machine, or if you are using an Intel machine, or if you are building for the actual device. So everything is going to be decided automatically when you run the application. The Cocoapod's Dependency Manager way instead is it will create a Cocoapod's repository inside the build folder of your project. So basically, inside that there will be the binary file, and then you can reference it from the Xcode project in the pod file. And this kind of thing is like you are referring a library in the build.gradle file. It's basically the same thing. And also in this setup, as you can see here with this bunch of bunch of code, the architecture and the target, so if your binary is for release or debug, is decided at kind of runtime, so when you're building your application. And that's how things work if you start with a new project. So now let's get more with more difficult things, and let's dive into 4 existing projects. Usually, and most probably, you don't have this structure in your project. Could be that you have it with a monorepo structure, but usually is not like that. So it will be really difficult to just create this kind of structure only for the matter of trying Kotlin Multiplatform, because maybe you have constraints on how things are built, or maybe you don't have time, and it will be difficult to just get this structure only for trying out, and then maybe you discover that Kotlin Multiplatform is not the right solution for you, so you will waste a lot of time for nothing. But luckily, in software development, we can just create libraries, so we can ship some code to other projects. So we don't have to build a monorepo, but we can just ship a library out of it. So we can start from some code that we want to share. But which kind of code? Well, it depends. Like almost everything in software development, it depends is the kind of way to answer. But some suggestion could be the part to start with could be boring code that is boring to write multiple times. Because if it's boring to write, then you get bored. And if you get bored, there will be errors in it, for sure, because you get bored. And also, other part could be code or feature that centralize the source of truth, because again, if there is a single source of truth, there will also be a single point of failure, so it will be better if it's only one place to fix. And the most important thing is that this piece of code should be code that can be gradually extracted, because you cannot, for example, start to extract the entire network layer, because if you find that Kotlin Multiplatform is not the right solution for you, then you have wasted a lot of time for nothing. So if you start by a little piece of code, and that can be gradually extracted, then you have time to validate your idea. But what are these piece of code in reality? Again, it depends. But for example, you can start from DTOs that you can write once and share it on both the mobile platform and even on the backend, if you have a Kotlin backend, of course. And that's where we started in my past company. And another example could be common models that you use in the domain of your application, or utility methods that every application have, or analytics code that is, by definition, the most boring code to write. And you name it. There are lot of other domain-specific code that maybe you're interested to share. All right. Now we can start creating our project. So in order to do that, we can either use IntelliJ or Android Studio plugin, because from the summary version of the Android Studio plugin, we can create also a library, not only an application, which is super nice. But in this way, we are not for Android. We are not having a shared Gradle file, but we need to ship a binary because we are doing a library. And for iOS, it's the only thing. It's the only way of doing things, so no difference in there. And in this case, we have to kind of build this library and ship it somewhere. maybe in the cloud, maybe in a USB stick that you give it to your colleagues. No, don't do that, please. And then this library will be pulled by the consumer. So in this scenario, there will be 3 different repositories where the different stuff are in there. Okay, now that we have understand the structure, we need to publish things for real. So let's start from the easiest part, that guess what, it's Android. And in order to ship something on Android, all we need to do is import the Maven publish plugin and set it up some stuff. In this case, the group and the version of the library, and just the coordinates of our Maven repository. And that's basically it. After doing that, we can publish our new version with the publish command, or we can even publish to Maven local. So in your local machine, if you have to try out stuff. And that's it for Android. That's everything we need to know, we need to do. And after doing that, we can just simply import the library in our project and start using that. So very, very easy. And now the hardest part, which are iOS. It was harder at the beginning to understand it because we can't use the way that we have seen before. Because, as I told you before, these 2 ways of doing things are deciding the architecture and the target before, and not before, but when you build the application. And in this case, since you are building a library, you don't know beforehand which target the iOS developer is gonna use. So you need to basically ship everything, and to do that, there are Xe framework that basically are the iOS counterpart of fat jars. So in there, you can basically fit everything. So you can put a different architecture, so for both for the simulator and the real device, and you can even put different platforms in there. So if you're targeting iOS, macOS, and whatever other things the iOS world has, you can do it. And this type of framework has been introduced recently during WWDC 2019. And before that, there was only FAT framework, which was where that you can use it to ship different architecture, but not different platforms. So for shipping to macOS, you had to do another FAT framework, which is a bit of a bummer. And now luckily it's better. Okay, there is official support on Kotlin side for Xe framework, but only starting from Kotlin 1.5.30. Before that, there wasn't official support, so you had to do manual things. And you had to basically invoke the Xcode build CLI manually. So since I'm lazy, I wrote some automation for that, but I won't cover it now. If you're interested, I wrote about it in my blog, but I hope that you're not stick to version lower than 1.5.30. So yeah, update if you can. Okay, so for new versions, to support the Xe framework, all you need to do, first of all, is do some Gradle configuration. So you need to firstly import the Xe framework thing. Then inside the Kotlin block, in your Gradle file, you have to create a Xe framework object. And then for every target, you have to add the binary inside your Xe framework. So basically, you have to do this thing for every architecture. So in this case, only for iOS. But if you have macOS, tvOS, whatever OS, you have to repeat this. And after this configuration, three new Gradle task magically appears in your project. So, and this task basically is they will build a debug and release a version of the XE framework. And when you call them, they will place the binary inside the build folder of your project. So you're going to have this structure, and there will be your framework inside the debug and release subfolders. So at this point, you have to ship those things. So you can either try it out manually, so extract from the subfolder and just drag it into Xcode. But yeah, it's okay for testing things out, but it's not okay for a scalable solution. So to do that, you need to use some dependency manager. So for example, Cocoapod. So I've always used Cocoapod, so that's what I stick to using it. So basically, you can create a Cocoapod repository. So can be a Git repository where you have a pod spec file where you define things like the build number, the version number, the name, and stuff like that. I won't go for time constraint. I won't go deeper on explaining how it works, but it's really well explained on the Cocoapod's website. So if you're interested, you can give it a look. So after doing that and having the library set it up, you can just pull your dependency in the pod file, like every other dependency. You can do it by defining the Git URL, and you can define either a branch or a tag. I usually use the branch for debug versions because, yeah, I iterate quickly, so I have I try different versions during the day. But for release version, then I want to be able to know which release version I shipped. So I specify a tag for that. Okay, so we have seen that there is a binary that we have to ship that binary. We have to build it, move it from folder, publish, and do a bunch of things, which I don't want to do manually because, yeah, I'm lazy. So I decided to create a Gradle task for that. So I can just hit a command and the machine does it for me. I have two tasks, one for the bug version, and this one is for the debug version, and what it does is just checking out to the develop branch of the Cocoapod repository. Then it builds the thing, and after building the things, it copy that from the build folder into the Cocoapod repository that I have. After doing that, it updates the version number inside the pod spec file by using the version number that is defined inside the Gradle project. So I have to define it once for everything, and I can forget about the pod spec file. And after that, it just commit the new version on the Cocoapod repository with a standard commit message with a timestamp because, yeah, maybe I want to find which version is not working, and then it just push everything on develop. And after publishing it, I can grab it from Xcode very easily. I have then for release builds, I have something similar that is basically doing the same, but for release version. And in this case, it's using, of course, the main branch for that, and it's building the release version. it's again moving from the appropriate from the build folder to the appropriate one, and it does the same. So it updates the version, the pod spec file, and all the ceremonies that we have seen before. But in this case, it's not. It's tagging the version, and it's pushing also the tags to my repository. And yeah, that's it for the building and the publishing. It was a rough path, but at the end, I was able to have a nice, two nice commands to just build the things that I want and to publish them without worrying about anything. Okay, so let's try to find some conclusions. So during this path of introducing KMP, I found and I faced and luckily resolved some difficulties. The first one that I found hard to begin with back then was how to organize the project without a monorepo structure, because all the sample online were with the fancy monorepo things, but yeah, it was not working for me. So in order to understand how to properly set it up, everything was a little bit painful, but yeah, with a bit of try and catch, I found the way of organizing in a satisfying way. Another thing which was hard that is connected to that is how to distribute the binary framework, because it was not clear how to do it at the beginning. Every sample was about the monorepo structure, so with the regular framework way with the Gradle Tasks. So yeah, it was not easy, and it required a lot of struggles. So after all these kind of problems, I found out a way of doing things about Kotlin Multiplatform, which could be summarized in this kind of framework. So what I suggest to do is to start little and then go bigger, because you have to understand. Because first of all, you have to validate the process of Kotlin Multiplatform. You have to understand if it's worth for you. You have to set up a kind of pipeline to distribute the things effectively, because yeah, you don't want to ship the library to the Android and iOS developer just with a USB stick, but you have to have a pipeline for that. So just in the beginning, you don't need a fancy one pipeline with everything, but yeah, you need the basic one, but it still requires time. So since you have to build some of the infrastructure, my suggestion is to focus on a little feature at the beginning. So if you see that this little feature is working for you, then you can go bigger. You can start to add more and more feature, and then you can live happier with some shared code. And that's what I did in my previous company. We started with DTOs, and it was a nice point to start with, because there was a time where I was doing everything. So I was doing Android, iOS, and also backend. So I was writing the DTOs 3 times, and I was sick of doing that. So yeah, it was why I can write once, and it was a really nice experience. It worked for us, and then luckily we hired more developers, so I didn't have to do it every time. But we were satisfied with the process, so we started sharing more and more, and we shared, for example, the entire persistence layer. So with SQLite, we shared the SQL layer, so I can make wrong only in one place. I can write bad SQL queries only on one place, not on both. All right. To sum it up, all the the code that I've showed in the slide during this presentation is coming from a sample project that I've published on my GitHub. So you can give it a look if you're interested. And this is basically it's based on the real project that I was working on, and it's basically a backend with Ktor that shares with mobile and with Android and iOS the DTOs. So it contains all the infrastructure that I've told you just now. All right, so these are some links that I used for building the slide, and then you can read them if you're interested. And that's it. Thank you very much for your attention.